Okay. Well, I just initiated our recording. Thanks again for everybody joining today. Hopefully we'll find this to be a educational session. Today's webinar, we're going to be starting to look at the 808D main control, and we're going to be specifically looking at working with part programs that have been programmed through a CAM system, imported into the control. We're going through a bunch of different steps handling them, and certainly Cycle832. Chris Pollock, I'll be your presenter for the next hour to hour and a half, depending on how quickly we get through the content. I can be reached at this contact information. I'm a DO support specialist with Siemens, and my territory is specifically East Coast. But no matter where you guys are located, you can always reach out to me as a resource within Siemens. We've been doing these live seminars now for maybe part of 8 months to a year now, and just to kind of promote some of the what are coming up. I'm trying to make sure we can get a seminar out about every 6 weeks is what we're shooting for. So coming up shortly, beginning of March, we're going to have a program guide for turning. So this is going to be more 828 and 840 centric, and it's going to be specifically on controlling a lathe G-code-based program. After that, in May, we're going to do the same kind of content for 828 and 840, but it's going to be boards milling systems. So keep looking for that. To make sure everybody's aware, these are our this is our main website. I wanted to make everybody aware of. This is our CNC for You website. A great resource for looking for all kinds of information. As well, either through the webinar link I have up here for you right now, or if you want to go to the CNC for You main site, there's a link that gets you right to this page. You can see what upcoming webinars are coming, and you can view all previously recorded webinars. As I'm recording this one now as well, the other ones get recorded. Please feel free to use it as a good resource for you guys. Send customers or colleagues to it to be able to gain more insight and information into the Siemens product. Okay. Specifically today, I mentioned just before, we are looking at the 808 control working with CAD/CAM-based programs. Once we start to go through some of the mechanisms of dealing with a CAD/CAM-based program, we're then going to even leverage our high-speed cycle, Cycle832, to try to improve the performance of such programs. As well, in the 2.5D world, we're also going to get an opportunity to not only build a Siemens posted program, but build an ISO program. In our world, an ISO program is like a FANUC style program, so following more of their protocols as far as CAN cycles are concerned. Some of the content we'll be going through this session. What we do is we start looking at our G290 mode, which is what we call our Siemens mode. Really, a lot of people don't realize it, but whenever you're in the Siemens protocol, and when I say Siemens protocol, it's just really what the commands are, how they affect the machine. You're actually running in G290 mode, so you'll hear me refer to it as G290 mode. So you don't have to actually tell it to be in G290 mode. The system does it all automatically, but you could in your part program if you wanted to. So this is going to be the example we're going to look at first. This is a little program that I created and posted out of Mastercam. It's a 2.5D cutter path. Traditional type of scenario that we would see in a lot of applications. We're going to do contour milling. So we're going to see a profile around the outside of the shape of this part. We're going to come in and do a helical bore in the center of it with an end mill, and then we're going to spot drill and drill 2 holes in the part. We get to handling the profile of the physical part. We're to have it posted with cutter comp as a where type of function. You'll see that a lot in CAM posted programs. What that means is the actual output cutter path is compensating for the radius of the tool. We're still going to see a G41 or 42 command turning cutter comp on, so you can still adjust the resulting cutter path. And there's some challenges when you get to working with some like that. We're going to talk about it, show a few different tricks, and apply that through. A few minutes just to do a brief overview of the jog screen. I have gone through some of this content in previous webinars on the 808, so I don't spend a lot of time going to the detail because we have a lot of content to cover. But when you see some of the functions here, when we switch over to the ISO side of the world, you will see some of these functionality. So I want you aware of what's here now. When we do get over to ISO, you're going to see what the differences are in the control. So this is a few of the functions we're going to take a look at quickly, but we are going to take a look at measure tool, measure part. This is what we're going to go into the offset table. We're going to actually build some tools as we start to methodize the programs and take a look at some of the offset areas. I'm going to switch over to our program manager section. And this goes into the area where we actually manage part programs. So we're going to start transferring files in and out of the control. We're going to build some directory structure, create file structure so we can copy programs in and out. Some tricks as to how to just kind of streamline how you methodize your parts and track your parts. From there, we're going to go into our event editor. It's a G-code editor. Start to look at some programs. We're going to play around with a couple different examples. I have these scenarios posted out for you, and we're going to get to see what the whole process is about in dealing with CAM-based programs. Simulate it to see an idea of what happened prior to running the system. And continue on, most likely even in an auto type of scenario. With that being said, we're going to switch over to my SINUTrain C, which is called 808 on PC. It is a machine tool emulator, and that's going to allow us to actually start to do some live exercises on this machine. So bear with me a sec as we switch over. Right. So everybody should have the 808D SINUTrain running right now, currently. This is currently booted up in an Axis machine model. This is a fully functional simulator, so I can go far as run a machine in auto if I wanted to. The system doesn't know nor care whether there's physically servos attached to it. So anything we do here is exactly the way it would happen if I was physically on the machine tool. Okay. What I did mention is that I did want to take a second and talk about the jog screen. The jog screen is what we're in right now. I can tell I'm in jog because the jog light will be lit as well. In the upper left-hand corner, it'll tell me I'm in jog mode. Here, you're going to see some key functions that we use quite commonly in the setup of the machine. First is the TSM window. It allows us to do quick tool changes. If I want to change what tool is physically in the machine right now, I see that I have 2-0, so there's no tool physically selected in the machine. If I fire up my spindle, turn off spindle. So it really keeps us from having to go to an MDI type of protocol to do some of these functions. I can go to measure workpiece, set zeros or set offsets. So I can find the part, I can find the center of a part, whether it be a block or a boss, and I can set zeros there. And these are very key functions when I'm starting to set up a machine. Same thing with the measure tool function. Measure tool allows me to set tool length. Tools, assuming I had a tool set up in the machine. I do not currently right now. From there, we are going to switch over to the offset screen. In my offset screen, I will start to create some given offsets and start to establish different tools and different tool radiuses. We have a couple tools created here. We'll start to go through, talk about those tools, creating a few more tools at this point. Right. From there, what I want to do is I want to transition over to my Program Manager section. Now, navigating through the different screens with this keypad on the right side of the display, you're going to see my mouse kind of hovering over it. With that, I can navigate back to the machine area. That's my jog screen by hitting machine, I go right to whatever program was last edited with this program button, or for what I'm now, I can select the program manager button, and that can get me to the area where my part programs exist. Okay. I'm going to part programs, and I'm going to start to come into the system and take a look at file structures and whatnot. Now you'll see that I have a few directories already here. I'm going to delete them. We're going to start from scratch a little bit. So I'm just going to go in and get rid of these directories. Don't cheat. Everything from scratch. Okay. So we'll assume that nothing's been done in this control as far as file structure. So first thing would be, navigating and finding where part files maybe reside or lie. Generally, in 808, you have a couple different ways to bring programs in and out. It will be determined as to whether or not it's an advanced system or a basic system. There are two different flavors of it. But what you have is you certainly always have a USB port. So that's what we're going to use for navigation and moving files in and out, is this USB stick right here. RC32 is available, and then the advanced system work capabilities are available as well. That being said, if you get my USB stick, I have a folder here where I have some part programs, and I have a few different programs methodized. So we have an ISO or FANUC-based program, and we have this Siemens-based program. This is that 2D profile. So what I want to do is I want to come in and I want to create a directory in the system, and then I want to copy in this part program to the machine. Back over under NC, this is our NC or system memory. This is everything that's residing internally in the control. I have an ability of creating either part program files or directories by selecting this new button right here under Execute. So by selecting New, I can pick a directory and type a folder name. And you can start to create different folders, and folders can be knit within each other. So let's say, for argument's sake, and I was talking earlier how I'm going to refer to things as G290, G291, I'll build a simple folder called G290. The G290, I select the K key, and it builds up a folder. From there, I can start to create other folders. I don't need to use folders. I can have part programs residing right in this directory. As you see here, I have an example one, this MPF file, main program file. So what I am going to do is I'm going to go into my G290 directory to be the source as to where I want to copy that program to. So when moving files in and out of the control is very simple. You're just going to use your cut, copy, and paste commands. So I'm going to select the USB. I'm going to navigate into it. So I'm going to use my arrows when I'm on the machine to my cursor around. I'll hit Put to go into a folder. If I want to back up, I just want to be on this top folder. I can hit Input, and it'll back me up. So I select Input. I go into this Siemens folder. I hide program, copy, select it's going to leave me at the folder I passed in. So now I can simply hit Paste, moves the program into the part memory. So now, if I back all the way out, I'm back at the root directory, if I went to the G290 folder, I see this part program. Okay. To open up a program, just simply highlight it and press your Input key to start me editing. It's a very traditional G-structured program coming out of a CAD/CAM system. You see a bunch of notes here at the top. So these are certainly very handy. So I have some tool notes, a few different tools defined for me, as well as maybe posting time, source files, that kind of stuff. Then from there, anything with these semicolons, so semicolons are what we call comments. So anything you want to put any type of user note in the program, just simply put a semicolon. Everything after it will be ignored. Then I start to see the header protocol, my tools, my tool changes, technology statements, and we can start moving down from there. My spindle commands, different things being fired here. So first, when I'm methodizing or setting up a new part to start to simulate and then eventually run, is I want to make sure that I have the appropriate tools created, set up for me in a tool table. I see T1 through T4. So I do, and I certainly have a little reference here on these tools. I'm going to go over to my offset table by selecting the offset key right next to my machine and program button, and that's going to put me over to my table or my work coordinate table. The list is the tool table, work offsets, where my part rows are stored. A couple tools pre-created, but I'm going to build new tools for you, and cheating and using the ones that are here to delete them, and we're going to build them out. So right now I only have 2 tools in my library, tool 8 and 9, which are used later for a surfacing program we're going to look at. So it's time to build a new tool. I'm going to hit the new tool option, and these are your 4 primary tools you get with the 808 control to build. Mill tools, tap, and ball end mills. So a tool would be a standard end mill, face mill, something along those lines. So in this example, I have a 3/4 inch end mill that do my primary rough machining around my peripheral. Then we have a 3/8 end mill to do the helical in the center. And then we're going to use a center drill, which is 3/8, and a quarter drill to drill holes. So select the tool number. Now this would probably be one of the first things you're going to see that's a blaring difference between the 808 and some of our more advanced controls like the 828 and the 840. And that's the fact that in the 808, you only can assign tool numbers as names. When you get to some of the other controls, you can actually get a little more creative in your naming terminology. Built a tool. I'm going to assign some dummy sets to the length. Traditionally, this will get set by that tool length function we saw briefly earlier. Set up my tools over right here. Ask for me for the tool radius. Now, I said it's a 3/4 inch diameter. If I want to cheat and not have to do the math externally, you can bring up a calculator on the 808. So in the input field, if you hit the equal sign, it'll bring a simple calculator for you. So here I can tell it what I need to calculate, and this is what's half of a 3/4 inch end mill. Hit up the key and into the field. So you can use that certainly in a part programming area. Just remember, hit the equal sign, and it'll bring up the calculator for you. So one is in the system. Now, tool 2. Tool 2 again is an end mill. I said it's a 3/8 end mill, so I happen to know that the radius on that's 187. Our length. I'll do a third tool, which is going to be a drilling tool. Tool 3. 3 in this case is a 3/8 diameter spot drill. So again, 187. I have to give it, obviously, the radius for a drill because there's no cutter comp associated with it, but I can. Sometimes it's nice from a reference side. And I'm going to do a final tool, which is one last drill, tool 4, and we was a 1/4 inch drill. So that's a 125 radius. Length. We have our base offsets set up for our tools. Now to jump back into my program quickly without having to reselect it on the screen, I can hit the program button. This is a simple shortcut key, puts me back to the program I was editing. So we can start to look at the part program. So we look at this program, we're going to see a few things right here in the beginning. We're going to see that they're going to do a tool change to tool 1. Load the tool here, physically loads the tool with the M6 statement. A corner rounding function initiated. Have some rapid, some basic header statements, what work we're using, spindle speed command. You see this T here? Important to pay attention to, and this is probably one of the first areas where the way the post is set up can dramatically affect how programs work. The post I'm using here, and the protocol that this is running from is really no different than an 828 and an 840. This is the same post that I actually use for 828 and 840 machines. However, this post was written for a machine that has a random style tool changer. So what this cheat code right here is doing is actually prefetching the carousel for the next tool. Unfortunately, this machine that we happen to be on is a carousel tool changer, meaning I can't randomly set up my tools. What you're going to find that commission the machine then create some interesting results. So we're going to run this program, and then we're going to try a couple of things, and we're going to notice that nothing's changing. And then I'm going to show you what's happening here. But these are the things you're going to start to have to deal with when you're dealing with post processors, especially debugging them. You know, a lot of times it's designed for one machine or one control. You're trying to apply it to a little different machine that was set up differently, and you make two very different results. Okay, so if we go to simulate and run this part, you're going to start to see the machine come around. It's applying some form of cutter compensation. Okay. Now, this is the first area that you have to start to pay attention to when you roll around the cutter comp. What's right now and what you don't know, which I already know because obviously I methodized all this stuff, is that we think that the machine should be running tool 1. The way the parameters are set up in this machine, it's in the offset based on the T code, not necessarily the M6. One of the things you might do would be say, well, what happened if I went to tool 1 and dramatically changed my radius to maybe a 0? What happened when I simulated it? I would get a different result. When I look at this profile, I'm still going around the exact same path. So how I adjust the radius on this program, it doesn't seem to have any resulting change. What's really happening is if I was to really run this part, it's actually in the offsets for tool 2 because they have set this machine up. This actual machine isn't designed for prefetching. Watch what happens when I simply just delete this instruction that's not needed. Now if we go to simulation and we rerun this part, now we see a completely different cutter path. It's important to start to understand how these commands build and understand that depending on the technology of the machine I'm on, they may function very differently. So, what I wanted to start to show you here, and this is very common when dealing with a hosted program where you're compensating for the tool radius already. On this, so right now, I have offset tool 1 set up at a 0 cutter radius. This would be the actual cutter path I would need to cut this part accurately. So if I put any offset in here, say I put it back to that 25 radius because this is a 3/4 inch ML, then I start to run the program, and we start it. Take compensation out. Now my part is now oversized. It's oversized by that radius. So this is center line of the cutter. You want to be careful when you're posting programs that, you know, how do I handle this? Well, you've got a couple ways to handle this. Probably the most common way when dealing with programs that they want to have stability of adjusting an offset out of the machine, it's called outputting from the CAD side, outputting where. It's still going to output a 41 or 42. I can see my G41 is here. It would hide it on me right there. So your G41, this is what's turning on the comp. If it wasn't there, this issue wouldn't occur. But since the 41 is there, I have to set up my tool with a 0 as my radius, and then as I adjust it, I can put maybe a small value here, and then simulate it. I'm going to get a new cutter path just off of that. On this, you can really start to see it. Let's move over a little bit. I want to get right in here. All right. So now see, all I did was, in this case, I put 25 thou, a little larger than I would in real life. I wanted you to get a chance to see the different cutter paths. So normally, this is how most guys run their machines when I'm dealing with CAM, and I'm outputting cutter compensation. They establish all of their tools at 0, and they'll put small incremental values here, plus or minus Like if I was to set this value to a -25, I'm going to now see the exact same path, but now there'll be a new line on the right side here. So there's a new line on the right, just estimation. And that's certainly a valid scenario to run your machines, and now you still have adjustability if your parts aren't coming perfectly to size without having to repost the whole file. If you get cutter competition on and you need to change it because an end mill was undersized or oversized, you have to repost the entire file and bring it back down to the machine. Now, if we want to operator put the correct radiuses here, we don't want this whole compensation we're seeing. Well, with Siemens Control, we have a neat little feature, and we have the ability to modify offsets within a part program on the fly. So what I'm going to do, and I'm just going to put it just somewhere just below my tool change, is I can do a statement called TOFR equals. I'm going to put a negative whatever the radius value is. TOFR sounds a funny kind of statement, but really what it is tool offset radius. So we're adjusting the tool offset's radius. I can use this as an L, TOFFL, and then I can adjust the length of an offset. What that's doing is it's saying, okay, I understand I got a 3S tool, but in reality, I'm going to take that 3S away before I run the cutter path, but you still cutter compensation. So if I simulate that same part program, I'm going to delete the window so we'll get a fresh simulation. The same results as I would have had before. Not getting double compensation. This part would have been at 2 inch. That's correct. Now I can just add, subtract to the diameter like a real scenario. So if I think it's a couple over or under, I could put the true value here. So let's say 0.4. I'll put a big number, for instance. And then, like we saw before, I get a simple 25 thou offset. And I'd come over here and put 0.350, jump over them, Cycle832, and there. It's just a nice, simple little trick when dealing with programs with compensation. Whether you use zero offsets in the tool table, very acceptable. Use true offsets. I like using true offsets in the table. That makes it a little easier for operators. You know, if you're up a half-inch end mill, put 250. And this way, if you know you're doing regrinds or it's undersized or oversized, you can put that true amount, and you're not always kind of guessing. This would be the trick, using the TOFFR statement. What I also want to show you here towards the bottom of the program is cycles. So this program drills a couple holes. So when you're dealing with CAM systems, the system itself, we'll go down a little bit further, go to our spot drill here, you see it right down here. This is going to output a CAN cycle. It's how CAN cycles look in the Siemens world. So you have an MCall statement that sets up modal drilling. 81. I go down a little further, you're going to see a cycle 83. So it's just a different type of drill cycle. When you're on the system, even though it was posted from a CAM, as long as you're using our CAN cycles, you can actually launch what we call a data mask. And what the data mask is our can automatically have conversational programming built into the cycle level. So I can open up the cycle, validate, or make some changes like, hey, I want to change the depth of my spot drill because it's a little shallow, without having to go through and repost it. If you're always letting the CAN system put out at point and not use any CAN cycles, then you start to lose the ability of making changes at the machine tool. Here, I simply say, hey, I want my spot drill to go -0.2, accept it. It's the appropriate field in the cycle. That would now apply as I run the program. But the other thing you're going to use this for debugging of posts. Probably the most common mistake that you're going to find a post that gets written undergo in the system, in the world, is how they build our CAN cycles. What you're going to do is when you're first checking out that post and validating whether the post is correct or not. You want to have them build up a bunch of CAN cycles. And then what you do is you're going to open the CAN cycle, and the first thing you want to look at is the blank spaces are here. Some are okay, but that usually tends to throw a red flag that you want to pay close attention because they probably are not filling out all the variables. So then I would just simply go through the resulting cycle and validate that it's all correct, that the depth was in the right field. Because if they built the placement wrong when they post it, like, oops, we were off a position, so we put the drill depth of 0.6 right here, one plane down, so now it's affecting a reference plane, or maybe I moved it up, and all of a sudden my depth is under my safety distance field. Those are the things that are going to get missed initially when you're first building a post-processor. So use this mask as a quick way to not only obviously modify the program once you're in production and making parts, but validating that the output code out of the CAN system is good in the first place. Okay. Now, I create a part, I'm ready to run. From here, to run a program in the 808, I simply hit the execute button, and that's going to automatically put me to my auto mode. I could run the part from the beginning just by simply hitting cycle start and letting the system run. We have what's called real-time simulation or real-time graphics. So if you hit the real-time simulation function, I'll put zoom on and delete the window. I can see real-time as the machine's running. You crank an override down and stops, the graphics would stop. So I could up, machine out my given part. Now, I'd like to show you real quick. One is how the stream of a part program, maybe pull away, check some dimensions, clear some chips, and return to that point and continue cutting. And the next would be how to just randomly start anywhere within the part program that I want. So in the system, running. So I'm going to crank my override down and give me some reaction. So it's running, it's cutting, it's doing its thing. I need to get in and check something. If you hit cycle stop, the machine now I have the ability of going to jog, moving up, in a safe position, doing what I need to do, and now she retained the point at which I stopped. And I never at one point hit reset. So you're still in a cycle stop state. No stop state. Don't reset. So reset will clear it. It'll lose that point that it stopped at. But if I'm still in a cycle stop condition, I can simply go back to my auto screen and watch what happens here. I got the crank down. It's going to vector. So it's going to short its path to the point I stopped and then continue cutting. So simply hitting cycle start would reset cutter, back down, picks up point, and continue cutting. Do this as many times as you like through the run of a program. You keep pausing and starting by cycle stop, hit jog, come back in. Now, what if I need to start midstream of the part program? Very common. We were running, we got through an operation, checked that out, it's all good. Now I want to move on to the next operation, but I don't want to start from the beginning again. You're going to use what's called a block search. Block search, I now have the ability to come and see my part program. So I can page up, page down, move wherever I want it to start within the program. So let's say I need to start drilling. So I'm going to go down to the drilling, but I'm going to start from a safe point, meaning I'm not going to start from my tool change. I'm actually going to start from submission after my tool change. It's pretty common, but it's very difficult to do on a lot of controls because they only want to start from a point at which it's going to have all the modal commands after that. In the Siemens control, you can from any location you want. So I'm going to come down. What I do is get rid of this for call. That is not valid. So I'm going to start right from here. I'm simply going to tell the system to do either to endpoint or to contour. Calculate to this point, set up modal commands, and start from this point. The difference between to contour and to endpoint, to contour wants to try to do like a lead in, 10 points is going to go straight to the point at which I'm at and start cutting. So select point. Now I can crank my over down, cycle start. It's a cycle start hit. First start gets it set. Second cycle start the program. I'm now down and running, and it finishes up my program. Anywhere you want within the control, just doing that mechanism. What we're going to do is let's break a second because I do see a couple questions coming in. I search by a block. Yes, you can. When I did that search command, I have a search field, so I can type in anything unique here. So if it was a code I wanted to type in or a block, I can certainly put that in. Another question came in just before. How many jog moves can I do before I restart? As many as you want. There's no limitation, at least that I know of, as far as number of jog positions. But remember, the system is going to vector to the starting point. So make sure you leave it in a safe spot where it's going to go shortest path. It's going to do potentially up to a 3-axis move to get there. So it's pretty common to move her away and then jog her back close before you restart the system. So then that vector isn't that great. All right. You came in a little earlier. 808 on PC. The software I'm using is fully available for download. You should be able to get it from our CNC for You website. It's completely free of charge. You have to kind of sign up and then register for it within the system. And once you have it indefinitely. And it can be completely used to actually program these machines from it. Great questions. We will do a Q&A period at the end as well for any other questions that may come up. What we're going to do now is we're going to switch back over back to my PowerPoint. Sorry about that. And now we're going to start to look at the ISO mode. So we're going to use the same part program that we just did, but we're going to switch over to ISO mode, and we're going to get a chance to see what we get, what we lose. So first step, whenever switching the control over, is you're going to have to go into System Parameters. I'll show you how to do that. We set our password. We have to tell the machine to really repower up into the ISO mode. And this is a little unique for the 808. On an 828 and an 840 control, you don't have to go through these steps. You can actually switch between the modes on the fly. But the 808, you specifically reboot into the given mode. You're going to see some functionality is going to change. So that's why I pointed out a few of those screens, like the TSM, like the measure part, measure tool. They are not available when you're in ISO mode. We're trying to make this kind of run more like an ISO-based program. So if you were to need to do a tool change, you'd have to go to an NDI screen. If you were setting an offset, you'd actually have to physically write the offset right into the offset table. Okay. So will be some changes to the offset table. We can see that here. There's a new H column. You see kind of there that's going to get popped up. Reason being is when you get to ISO-based programs, they call up the tool type separately from the T code and the G43H number. It's to correlate to an H column somewhere. So this is part of the reason why you reboot the system, because it actually activates this type of functionality. Then we're going to look at the part program. And for those of you that are experienced with ISO or FANUC style programs, you're going to see this is really posted directly for a FANUC machine. No editing needed per se, just no percent signs, and you just comment out the program number. You don't need the program number. It's a direct drag and drop into the system. See the simulation functionality. Then we're to run, just so you can get a feel for how it runs and what it looks. It's not like it's parsing it into R's or doing anything funky. As far as the operator is concerned, it looks like it's just running the straight ISO protocol Let's first learn how to switch the control. What you need to do is you need to go into the machine parameters. So remember, we've been using these buttons in the upper right-hand corner: Machine, Program Manager, Program. We have a button called Alarm. And above Alarm, in text, is System. Well, if I just hit the Alarm button, it's going to bring me to the Alarm screen. Alarms that may be this system can be viewed within the screen. But if I hold the Shift key down, now going to Alarm mode, the same button is going to go into the System Parameters area. And this is how you need to get to the ISO switch. So you want to hold your Shift key down, the Alarm button, and push over to the machine configuration area. Now, what we're going to do is we're going to hit this ISO button. But by hitting it initially, it's going to say that you don't have the access level to the control. This is dependent on access, so it really keeps an operator from inadvertently switching it, if you don't want a guy to be able to do that. So what you have to do is you have to set your machine password, your access level. So right upper corner on our screen, you see a set password function. Set password, type password Sunrise, S-C-N-R-I-S-E. Type accept, and you're going to see that it switches the access level over to manufacturer. So once I'm at manufacturer, I hit the ISO button. It's going to do a reboot. Okay. The system's going to reboot. It's up into ISO mode. See this little red ISO symbol? It points up, and that's because this machine has incremental encoders, the one that I happen to be on right now. So it is wanting me to just re-reference the machine once I've switched modes, because I did, all intents and purposes, repower up the control. So I'm just going to do a quick referencing procedure. Machine's now homed. If your machine is equipped with absolute encoders, the advanced systems can be, then you wouldn't obviously have to do that. I am going to set it in metric or inch to switch the control on either mode between metric and inch. Just hit the settings button while I'm in jog, and then hit this button right here. Okay. And do inch mode. So now I see 4 decimal places telling me I'm an inch. I'm now set up. So I said it earlier, just a pick on the PowerPoint, but here you can start to see the buttons are now missing, and that's because you're ISO mode. The ability to set relative zeros, but if you want to actually write to any offset tables, you have to physically go to the offset table, work offsets, and enter what the offset value is. And that would be the value right here, this machine coordinate system value. Okay. Now, what you do, and very important, is you get the A column. The column is required to be able to start running the part programs. The way the H column works, and you'll see it in the part programs as you open it, is it's generally matched to whatever the number is. So if it's T1, it's going to be H1, T2 is going to be H2, so on and so forth. It doesn't have to be. That's typical standard. So set up my H's now while I'm in this screen. Keeps me having to do it later. Set up H4. Okay. So from here, we're in the mode. I can go over to Program Manager. Now I'm going to want to come back. I'm going to create a directory like we did earlier. I'm going to call this my GD1 for ISO mode. So for all intents and purposes, maybe this is where I keep all of my ISO-based programs. I'm going to go over my USB stick. The same scenario like we did before. So navigate to the appropriate folder, program, copy it, go back over NC memory, put it into NC memory. Okay. From here, we can open up the program. Navigation, everything stays identically the same between both modes. So you can bounce out of them. You don't have to relearn the control or anything. But what you notice, so programs, we're a little bit more liberal on form extensions. So like here, MachineToolProducts likes to programs with a .NC extension, numerical control extension. I didn't have to write this to an MPF extension in this control. I'll leave it at NC and it would still allow it to fully run. You know, traditionally your G290 programs, your Siemens programs would have a .MPF standing for main program file. So now we have to see what the part program would look like, and very, very typical. G20, this would be inch mode in the ISO protocol. G17, G40, 49, standard header statements, G80. To do tool change, we have tool change protocol right here for you. We have other, like, absolute, setting up our spindle commands. So this would be what you would normally set up. Now, here is your G43 offset. So here we see H1 being called out at this point. It's to maybe search down to the next tool, which is a tool 2. Now you're going to come down and see the G43 A2 field. Okay. And so forth, right down through the part program. Keep going down just to show you. We can go down to our drilling cycle and show you this is your standard drilling cycle. So your traditional GA1, depth, R, feed. So there's a direct dropout. There's no editing needed. Like I said, just get rid of your percent signs if you have them in the program, and no program number at the beginning. And that you can start to run right here. So if I want to start to simulate programs that are run, I can do it the exact same way I did before. I can jump over to simulation to delete the wind here, start from scratch. I want to be in auto when I'm simulating, hit cycle start, and away she goes. Now, I see I get this heavy offset, nice big arc. That's because this is double compensating again, like we saw earlier. This program was written, let me jump. Program was written for cutter compensation with wear. So come down here to the line N170. There's my G41 cutter comp line. Well, because of that, just like we saw earlier, if I have a rate here in my tool, I'm going to try to use it. Now, finally, I do not have, that's not happy. Do not have the, do that. This number does not exist. Love these. Okay, I'll try to simulate it real quick. I do not have the ability, and I'm going to have to reset this. Bear with me 1 second. I'm going to machine down and relaunch it. Ability of doing that radius trick that I was showing you before for Siemens side. Those upper level instructions or functions are certainly things that are reserved to when running in R mode. So that and a lot of other commands, as you start to get more in depth in the control, you start to lose when you're in ISO mode. So just be aware of that. Aware that you are going to compromise or give up some functionality or features when running within this mode. So let's jump back in. I want to just resimulate that for you. Excuse me for having to reset the machine. It's a PC. Gotta love it. Okay, so I come in, cycle start, put our mode, and now see our fluid sweeping arc. With that, ISO-based programs, when I'm putting on cutter comp, I've already compensated for the tool. I do need to set my tool radiuses at 0, or I'll get double compensation, just like we saw over on the other side. Now, as well, program exactly the same in either mode. So simply select execute, start, program. I can do block searches. I can stop midstream, just like I showed you. All that functionality still exists. You still have the graphics. You still have all that functionality available for you when you're in ISO mode. What I probably recommend, if you're going to try to leverage the machine in this mode, you're probably going to find you want to do most of your setups you have all those extra tools, the measure tools and all that available to you, which are great features. You're probably going to want to do all the setups while still sitting in our standard G290 mode or Siemens mode, and then just simply switch to ISO mode when you're ready to physically run the program. Okay. So that's a quick overview of the ISO mode. What we're going to do now is we're going to switch gears a little bit, and we're going to start to look at more higher technology type of features or functions. So we're going to, let me just shut this down for a sec. We're going to go back to our PowerPoint, and we're going to keep jumping into the wrong one, excuse me. We're to talk about what I call 3D surface machining. In this scenario, we're going to take a part that was machined as a three-dimensional surface file, and we're going to start to play around with it and a couple different ways to utilize those programs on the control, give you a couple little tricks as to how to work with those types of files. They can be pretty substantial, so you will want to, certainly get a chance to start to see some of this stuff. And this is definitely areas where we're going to get in and start leveraging some of the advanced functions, high-speed cycle for our argument's sake. So what we'll be doing here, we'll be going in. I'm going to show you, the thing we're going to look at is what you traditionally see coming posted would be a large program file, has all the operations in it, so all the operation will be contained in one program, and we're going to bring it into the control, but the file is so big that it may potentially fit in your control. So I'm also going to show you how to execute it from an external device. So we're going to look at it two different ways. We're going to look at some posting errors as well. We're to look at some normal posting issues, just as, like showing you earlier, with like T-code, where that was applied wrong. Here you have some older technology cycles that are being triggered. So we're going to talk about those a little bit. Let's start to show you a little bit more progressive in the industry, but it's a way of matching these more complex part program files in subprogram main program structure. So I have it pre-created, but what you would normally do is have a simple main program structure at the machine, and it'll call up, and each of your operations, so in this case, I have 3 separate operations to machine this part. I rough it, I semi-finish it, and then I finish it. And I'm allowing the main program to bounce between 3 separate small files that contain really the cutter path. You're going to see this becomes more and more popular in the industry as ways to deal with large files, large file structure. Then we're going to start to use some kind of unique statements. I'm going to show you how to use some R variable statements to be able to pass data from one program into the other. So I'm using it for my feed commands and my speed commands. So I don't have to ever go into the subprograms and make any editing changes. I can actually edit them right from one simple point in my main program, and the results will affect me in the sub. I start to use go-to statements for quick jumps in navigation. Certainly I can use the block function. It's a great and powerful function for doing kind of stuff. But you're going to find go-to is also a very, very powerful tool to move around through programs really, really quickly. From there, we're going to start to look at our high-speed cycle and count the high-speed cycle a little bit. I certainly want to run the program, come to the baseline cycle time, and then show you kind of what's going on. Now, when using Cycle832, our high-speed function, let's take a minute and talk about it. The interface screen is pretty simple. So you're defining a tolerance, and that's what's called a chordal tolerance. So I'm going to show you what that is in a second in the next slide. And then you're defining through the TOLM field, really the technology. Are we roughing, finishing, or finishing? From 2 statements, all kinds of back-end things are done. In legacy-based controls, you have to either program a lot of this stuff discretely, and we would find inconsistent results on the machine tool because a lot of times guys were just triggering the wrong cycles and didn't know when to leverage which cycle and which. So we've taken a lot of that out of the scenario by putting it all in the back end, and you just tell us, hey, are you roughing, you finishing, semi-finishing, what's the tolerance. And then this way, too, we don't deal with cases where the guy's calling up a legacy cycle and should be using a newer one. So it kind of takes care of it. But being triggered in the back, some of, and not limited to, but certainly some of the key functions is first the compressor function, and we see that in the upper left-hand corner. There's also a good slide that starts to talk to you about what the chordal tolerance is, that fifth out tolerance I had before. It's really a value that gets passed from the CAM system, and it's really how far we allow the point that's being output in the part program to deviate from the original curve of the piece. So if you can, you want to use the same value that you're using over the side of the world over here. It's going to make everything be a little bit clearer. If you don't know what it is, use standard rule of thumb, at least starting out. If I'm roughing, I usually put about a 5 thou chordal tolerance. If I'm semi-finishing, I typically drop that to a thou. And then finishing, I usually set that to half a thou, 0.005. At least a starting point, and you can with it from there. Move it up, move it down. But if you know what that value is, a discrete value, you will do a value. Now, what is the value really doing? Well, what it does on our end is in CYcle832, we're doing what we call a compressor. And what a compressor really does is it's taking these point-to-points that you just gave it in this part program, and we're transposing a spline or a curve through all of these points, because what we're trying to do is we're trying to figure out what the original curve of the part was in the first place. Systems have a hard time outputting splines, but the data they're storing in their system is actually a spline. They had a hard time outputting them because typical controls could not read splines. So they had to put everything into these point cloud type of scenarios. So what we're doing is, for all purposes, we're really reverse engineering your part. We're exposing the spline through these series of points, and your chordal tolerance is really the reason as to how free we can make this spline to try to figure out what the shape was in the first place. When we run the actual spline. Other commands that are getting stated is like G664 or G645. These are look ahead and corner rounding functionalities. We have our feed forward commands that will be being on or off with our jerk location functions. Feed forward soft, feed forward brisk. There's a few different technologies. This, as well as a bunch of other stuff, is everything that's being turned on in the back end when you start to utilize 832. What I'm going to do is I'm going to fire up my machine again. So let me just share that real quick. So we're back into the machine, and we're going to start to look at some and play around with them a little bit. So first things first, I'm going to navigate over. Now, I switched it back. That's what I was doing before when I shut it down. I switched it back into the Siemens mode because this program happens to be methodized in our G290 Siemens mode. So we're just going to jump over to our program manager, and we're first going to look at the complete part program. I had it in here, so I'm just going to delete it for now and bring it over. Okay. There's two ways. Old school, or your probably most common history, is to physically post the entire file as one program. So in this case, it is about a half a meg file. Not too big, it's not too big a surface, but these files get big really quick and also become pretty unruly as far as to navigate them. So we're going to get into memory first. So I'm going to copy and I'm going to paste it over. I'm just going to put it in the root directory here. This surface program, it's the same kind of method, assuming it fits. Now we're going to open it up and we're going to start to look at it. So when I start to actually navigate through this program, I'm going to start to see that it's big. It's big. I mean, I can keep going and going and going, trying to navigate through this program. So if I have to do any editing changes, if I need to validate anything, it seems pretty tricky. I have to navigate all the time. I have to use my searches to try to move around through the program. Okay. So if I still look at the program, see different features. One of the first things I want to point out and show you, and you guys saw this command a little earlier, is this G641 ADIST equals. Now what that is that's actually a pretty old command. That's the corner rounding function that I earlier talked about just in the slide we looked at with the G645. G645 is just a newer version of this function. We are always what's called upwards compatible. That means is we always want to allow programs that were written for an older control to be able to run in the new system. So rate of commands. But I want to change the functionality of a command all the time because that can get a little messy. So sometimes we'll just build a new cycle. So originally we had G64, then we went to G641, and then we had a G642, and now we're up to G645. Well, right now I see this cycle. What that tells me is this post probably hasn't been updated in a good 10 years. We haven't, we've had higher level cycles in G641 for easily 10, if not 15 years. So it's very common when dealing with post processors. And this is part of the reason why sometimes it's nice to just not deal with the technology tied to the functions. You know, as a control manufacturer, we're adding things all the time to the controls, and a new control come out. These guys are playing catch up all the time with these posts. So start to kind of follow the logic I'll show you next with breaking up the part programs, then certainly it makes it a little easier. They don't have to worry about making sure everything's up to date. Okay. But if I can navigate through, I need to start using my search functions. You know, maybe I wanted to get to tool 9, so I could search down to tool 9. You see we're already at block number 9600. There's my blend mill. But again, see these statements are riddled through. So if I have to start editing and modifying them, now I got to jump in all kinds of different places throughout this program, make sure I get them all. It's a complete program. I can still utilize it the same way. So certainly you can go over to simulation, simulate the cutter paths if I want to. It's about to happen. I can look at it in different orientations. So we can maybe look at a front view if I want to see what's happening. We have a 3D view, or 3 view, shall I say. Just looking at it, a quick little top view here. So roughing it out, system would come over, roughing out the contour, and then we're going to finish it in the other direction. This has a much finer step over. It's using a much smaller tool to do its final finishing path. Certainly, surface files can be simulated, just like you could simulate the standard files, as far as 2.5D files like we saw earlier. So this is nice because at least I know if there was some kind of syntax error in the middle of the program or something got posted funny, I would see an alarm right now. I would know what's going on. But I could go over to execute. It'll start, and then all the features we saw before, starting in the midstream of the program, I can do any of that kind of stuff. Now, what happens if that program, this large file, doesn't fit in my system? So let's say, for argument's sake, this is the scenario we have today. So I am going to delete the program. So on the 808, as well as our other controls, you have the ability of running programs from any external surfaces, external memory allocation, shall we say, or devices. So just like that, I can be on the USB. Now, limitations to the 808. Front, I can't edit the file while it's on an external device. If I hit the input key or I try to open it any which way, it won't open. You would have to, if you needed to make any editing or modifications, do it externally. But what I do is I use this execution button right here. And that's what's going to put the system into memory. It's automatically going to switch me to auto and get me ready to run. So this right now, as I hit cycle start, this is physically running off of the USB stick. Procedure, however, you got to make sure you go Program Manager, highlight the file disk. It could be on a network drive, it could be on RS-232. Hit the execution button. External execution is what it stands for, EXT, execution. Then start the program. Now what we'll do, though, is now we're going to switch gears and look at methodizing this part with a main program subprogram structure. So what I've done is I've already set up a stick, a full structure called tuning. What it contains is in this case, 3 different operations that I'm going to use as subprograms now, and a little main program that I wrote. So what I'm going to do is I'm going to copy my folder and put it over here, surface machining folder, and it brought all of the files in the subfolder with me. So I can grab large chunks of data, bring them over in one shot. So I'll leave it in NC memory just so we can kind of come in and out of the files a little bit. So what does the surface program entail, or the main program, shall I say? Well, I'm going to do all my tool changes in here. I'm going to set up my high-speed technology statements here. I'm going to call up whatever the programs are from here. I'm going to do my safe retract acts, my shut-offs, all I could set up in the main. What I'm really leaving the part program up for, which now is a subprogram call, that is simply going to be my cutter path, allowing the CAD system to do what it does best, which is output cutter path. So one of the first common things that's always a challenge is how do I deal with speeds and feeds? Certainly I could have my speeds and feeds up in this main program area, and I could have totally left them out of the subprogram, and I'm going to open up this first roughing program so you can see. Or what I have the ability of doing is I have the ability of leaving the speed and feed commands in the program. So if I scroll down here, I'm going to do my speed statement. Here's my S. And instead of having an S with an RPM, I can substitute an equal sign and an R variable. R variable is written to one of 2 ways. Is going to be if the main program is seeing it. So what I was doing before in my little program is I was right here with my R30, so telling this thing I want this thing to run at 4,000 RPM. There isn't any values set up in your part program. What this automatically does is go over to the offset table, go to R variables, and look for R30 in this column. You don't want your R variables in the part program. Maybe you don't want operators going in and editing that. You can go to this column right in the offset table, and they can write them right here. But it's always going to utilize what's in the part program over what's sitting in this table. So there's only a secondary if it doesn't get written anywhere else. As well, I did the same thing for feeds. Here you see we have some R's, R20, 21, 22. If I go back into my roughing program, it's mimicked all the other operations. We now get down to the feed statement. Right there's my feed. F equals R20. It's that simple. And you use R variables in the middle of CAN cycles. You can use them all over the place. So if you want them, feel free to kind of manipulate a little bit. Now, a couple of the other modifications I did in turning this into a subprogram is I commented out, I've deleted, certainly. I commented out all tool change commands because I want to do that up in the main. I don't want to have nested tool changes. I commented out any kind of advanced technology cycles, corner rounding, forward functionality, anything like that. I don't want here. I want pure cutter path. Either I want the spindle and feeds is really up to you. I'm not that concerned because I'm passing them through with R variables. But you don't want to have operators to go into the subs to make any editing changes. The area they should go into, if any of them, would be certainly in the main program file. Sent out these lines. If this was a real part that I was going to do in production, I would just delete them. No need to see this kind of stuff. And then from there, the part program, it's a matter of setting up my normal header statements. G&D absolute, G94 inch per minute. 17 is your standard XY orientation plane. G100 is a mech mode. I'm using my SUPA statement. This is a rapid retract statement, so it suppresses any work coordinates, cancels my tool offsets. That's what the D0 statement does. Put it into a rapid mode and the machine to go away. This stuff, if you're not familiar with it, I certainly recommend go back to my earlier 808D milling webinar I did a few months back. We go through all these commands in a lot more detail because we actually write a live exercise. Work coordinate, whatever work coordinate you want to use. I can use this go-to, and we'll use this in a little bit to jump around a little bit. We talked about that one. Then tool change. Now you see, I like to put this D1. This is what system, what offset I want to load. You don't have to. Earlier we saw they were using the D command because the system will automatically load based on that command if the parameters are set up that way. That was why we actually had the problem we did with the prefetching, because this one's machine set up to load tools on the T code, but once you put another T code in, it supersedes the last. Okay. So now there's our Cycle832, and we'll start to play with this here in a second. And then this right here is how I physically call up my subprogram. The system is smart enough that if you just give it simply the name of the file, op1_rough. Back up here, op1_rough. Don't need any extensions, nothing. So just simply give it the name of the file, and here, op1_rough, and the system will automatically start looking within its own internal memory where it finds that program, start to run that program. Now, if the program exists outside of NC memory, meaning it's sitting on a USB because it was too big to fit in the machine, sitting on a network drive or RS-232, then what you would do is you would use an external call statement, EXTCALL. So I'll start to play around with this a little bit, and you want to call files that aren't even in machine memory. You can do that to use an EXTCALL, external call. For change tools, again, in this case, I'm using the same tool. I repeated the tool change statement. It's redundant, but when I'm bouncing around, it allows me to bounce a little further down the program. So I can jump over this tool, but still force a tool change down here if I have to maybe just jump over to the semi-finishing operation. Scenario with my finish tool. So finish tool. I showed you a couple different ways to call it. I can use the call statement like I did in these next two. And in there, you type in call, and then in parentheses, and then quotations, again, the name of the file. So you either just write the name of the file, or you can type in call if you like. It's a little more structured. Either way, you'll find we're very forgiving with a lot of type of commands in that way. So we load it up. Down here in the bottom, I'm doing my normal shutdown. Shut off my spindle, shut off my coolant. I'm cleaning my tool, so I'm clearing my spindle. I'm disabling my tool offset. I do a quick change to actually clear the spindle. I use super command again to stage my tool, or to stage my table at a safe point for loading, and I shut off my program. You can certainly simulate these programs. If I delete the window, and if we were to run again, I can fire it up, and it's going to do what you saw before. So here it's already in and running the roughing cycle. And from there, once it roughs out, it's going to jump over to the other two operations. So even with subprograms, I can still simulate. There, it just jumped over to the other one. Then you'll notice as it gets down past this one, it's going to even jump into the finish cycle. So you still have all that capability you had before. So there we're into the finish cycle. It's rolling around it. Great way to let it run through just to make sure that there aren't any errors or problems prior to physically running the part program. Now it comes time to run the program. I'd simply go to execute from while inside the main. So this is all our main. Now I start to run it. I'm going to crank down my override a little bit. See how the current program's surface main? It's where I am right now. As I go start and run it, once it jumps in, it's going to always tell you where it sits. So you're never even kind of wondering, gee, which of the subprograms I am. To the screen. Right now I know I'm in my op1 roughing. As I start to crank up my feed rate, I finish a segment of it, you're going to see it's going to jump over to op2 semi-finishing, and then even to op3, the finishing routine. So always kind of keeping track of where you are at that given point. All right. There you go. Op2 semi-finish. and then go along. I'm gonna kill now because bounce around. So let's say, for argument's sake, we were running. We proved out the first two operations. We want to work on the finishing operation, but I want to run those cutter paths there. I would absolutely use the block search like earlier, but what we can also do, you can start to use this go-to statement. Hey, note as to where you might want to start from. So I'm going to start from line 210. That's just a quick retract away, just in case I left the tool down. And make spindles off, coolants off. It's going to change tools to tool 9, whether it didn't. And it's going to load up my cycle and start running. Let's go to this go-to, and to go to call 210. Now I'm still running the program from the start. So I'll hit it right from the start, but watch what happens. It's going to jump right to tool 9, right to finishing, starting the program. You have the real-time simulation you can bring up if you wanted to. What I'm going to do right now is I want to run the cycle and record a cycle time. And then I want to start to show you the result as we start to change the technology within Cycle832. Also do is start to look at some of the commands that are set up and some of the commands that are being triggered. So we have a baseline cycle time for this operation of 7 minutes, 48 seconds for a run, real time on the machine. Now, let's talk and look at what Cycle832 is really doing in the back end. So when I first start up the program, I'm going to turn the G-code function panel right here and hit cycle start. And still up. Haven't gotten into that program yet. I still look at it. I have a G64 enabled. That's a base corner rounding function. I do already have some feed forward function on, so that tells me that the builder, whoever committed this machine, wants that running all the time. That's pretty common. I see the G290, right? But it's Siemens mode, so it's there. I see our dynam norm is sitting at normal. So I see that's changed. About it. Not a whole lot technology-wise going on. So now I let the system in and start running. Now change. One of the obvious things I'm going to see is G645 right here. So it's where it's switched. So the Cycle832 is what's now triggering a G645 corner rounding function for automatically. You don't have to know that. It's also doing is it's also turning your compressor off. And that's ComCAD right here. That is what's turning on that spline interpolator. That's what's taking these points and transposing a spline through them. This starts to increase the speed and quality and tolerances of the part program as it's running right here. Well, the dyne norm was on before. Now I'm in a dyne. That's because I'm in a finishing routine. As you change from roughing to semi-finished to finishes, you're going to see these different statements change. And that's triggering a whole bunch of stuff in the back end. So this is how I can validate that Cycle832 is actually doing something, because I start to see all these commands being as I go. Okay, so we have 1 minute, 48 seconds if memory serves me. What would happen if I was to go into the program and change 32 right here for our finishing options? I could certainly choose a different technology. So we're finishing now. So what finishing means is I'm most concerned about surface quality and part accuracy. And that's why both of these arrows are blue. When I switch it to semi-finishing, I'm not as concerned about the surface quality, but I still want positioning accuracy. But speed starts to become an issue for me. So I'm more concerned about cycle time. And when I'm in rough, I'm really concerned about cycle time. That's why my velocity arrow was met. So if I simply change this to just velocity mode, I don't change anything else and hit accept, and then if we rerun it, let's see what difference we see. Oops. Let me reset this so we get a little bit truer count. So let's see if that makes any change. Some will be more dramatic than others. I'm going to show you in a second. We're going to put a real tight tolerance on it, really choker, and you're going to see it's going to add quite a bit of cycle time. bring my auxiliary functions, and come down. So we shave 10 seconds off, nothing too dramatic. While running, I would have seen the done would have been at rough. So I'm starting to see a little bit of a result change. Now let I go the other direction, and I try to, instead of freeing up the cutter path, I try to really start to constrict it. So I'll go back to Cycle832, hit my file, change my technology to finish, but it's all the way down to a 10. So now go to execute it. Run it. You're going to see the same kind of results at the machine. And certainly there's going to be a little bit of trial and error. You know, what tolerance is going to give me my most desirable positioning accuracy and finishing. A lot of guys think put as tolerance as I can. Well, that's not always great. A lot of times that will hurt your surface finish because you're restricting the cutter path too much, and you get a lot of imperfections in your surface. So now, just from dropping from a half-thou tolerance to a 1/10 tolerance, I went from a 7-minute 48 cycle time to 11-minute 42. So what's that? 4 minutes increased. So on a not even 8-minute cycle time, I took that and almost added 50% to that cycle time. It's quite a bit, especially if this was a 2-hour cycle time. You're going to start to play around with this. Again, keep the 3 different functions in mind. You know, what I did on mine was I was roughing it horizontally across the part, so I just let it go wide open with a roughing cycle here. If I was using a technology 3, had a tolerance of 5,000, just letting her fly through it. Then from there, went into a routine. Now I was following the contour, but staying away by a certain amount. I think I left 20, 30 thou on the surface. So now if I looked at it, I was tightening up my tolerance, and I was down here in my finishing. My two low diamonds were triggered. There, I went to the full finish. This is where I was really concerned about my dimensioning accuracy and the quality of my part. Okay. So, with that being said, to kind of open it up for any extra questions that may have arisen. I know we're getting close to the hour and a half allotted. There's a lot of content there. I got some thank yous here from some different people. Oops, sorry about that. Any of the questions you guys want to ask, just go to the Q&A panel, and you can type them in here. I'm just looking through to see if I missed any from earlier. I think we handled quite a few of them. Yeah. Okay. Alrighty. If anybody has any questions at this point, feel free to type in. There's a question. Was from post-processor I used for this as opposed to the 840 control. I did mention earlier as well, but let's briefly talk about that. It isn't. It was the same post-processor. Certainly, some of the critical things that we were talking about was really just those slight machine differences. Be careful, but the core code was the same between the 808 and 840. Certainly, the difference is this a shop mill type protocol that you get in the higher controls. Does next, being Siemens PLM, give better results compared to other post processors? Well, I would have to say, in some respects, yes. We tend to work a lot closer with NXCAM than maybe we do with some of the other external CAD CAM companies. So I think they've gotten the handle down probably a little closer, so there seems to be less hiccups every time a new machine goes in on bugging a post. I do work with those guys quite a bit. So, I work with all of them. So, I work with guys at SurfCam, certainly guys at MasterCam, and they're all pretty solid. Always going to be a couple hiccups in the road when you're first getting that first system up and going. Okay. All right. Well, I know we went quite a long time, so with that being said, I think we're going to wrap this up now. I want to thank everybody for taking a chance to join us here, and keep looking for some others. I will send everybody out the link to this recording. By all means, you can review it, send it to friends, colleagues, customers. By all means, I'm going to shut off the recording now.